Here's a problem about a rotational problem about a plastic disc. And what's happening with the plastic disc is, well, a couple things. It has a mass here of 0.2 kilograms and has a radius of 0.2 meters. And what the problem I'd like to know is what torque would you have to apply to this disc here to get it to go from 0, in other words, not rotating at all, to 1800 RPMs in 4 seconds. What torque would you need? So a lot of nice stuff in this problem here. The first thing I'll do is, of course, like usual, I'll convert the 1800 RPMs to radians per second. And if I do that, there's another video on how to do that, I'll get 188 radians per second. So the question can be rephrased as what torque do I need to go between 0 and 188 radians per second in 4 seconds. So the first thing I'll get out of this problem here is the angular acceleration that's needed to do this. I know the angular acceleration then is there's sort of equation 2, solve for alpha, omega naught minus omega over delta t. So what I have is the thing is definitely starting at 188 radians per second. And it has a delta t in the bottom end of 4 seconds, so that's how long it all happens for. So I get an angular acceleration of the system of about 47 radians per second squared. So that's the angular acceleration that's needed to get this disk to go from 0 to 188 radians per second in 4 seconds. So where would the torque come from then? Well, we have this analogous expression which we're sort of using as we go through this rotational motion stuff here. In particular, if we know that F is equal to ma, this is our good old relation from a few weeks ago. Now, we're not using this here directly, but if F is like torque, m is like the moment of inertia, and a is like alpha, tau is I alpha. It's sort of like the F equals ma for rotational motion. So we just found the alpha. You just stick it in there. That's our 47 radians per second. The torque is what we're looking for. So we just fill in something for I think we'd be all set. Where does I come from? Well, if you look in your textbook in the rotational chapter page, there's a big chart which gives you a bunch of moments of inertia. So if you look at the chart very carefully, you'll see something that looks like a disc like this with an axis going right through the center, and it'll be a radius r, and right next to it it'll tell you the moment of inertia is 1/2 mr squared. So in other words, the moment of inertia is a structural parameter which has a lot to do with how much mass the disc has and what the size of it is, the radius in there. The 1/2 is a purely geometrical factor which comes from the fact that what you're doing is rotating something that resembles a disc through an axis right through the center. So 1/2 mr squared is the moment of inertia of the disc there. So we're pretty well suited just to wrap this problem up then. We can just say that the torque then is 1/2 mr squared times the 47 radians per second squared, which is the angular acceleration. So tau is I times alpha. You can put all the numbers in with your calculator, but that'll make that problem work out.